Okay, in the last video I was looking at the single value boost limit, which is this little pointer right in the corner here. It doesn't really show, but it's there. Prior to that I looked at the basic boost limiter map there, and then these two boost maps here. I'm going to go back this way. I'm just going to click here and keep clicking until I go back this way, because I'm looking for another obviously recognisable map, and there it is, and there's another one there. These look suspiciously like N75 maps, in other words the boost actuator maps, but I just want to point something else out while we're here. If I run that way, look what's appearing. What looks like a smaller version of that. And if I just jump, I'll just scroll the wheel now, but 1, 2, 3, 4, there's more of those possible N75 maps there. Now if I go back to the boost, remember, the boost seem to have more other versions of boost here, or something to do with boost here. So the fact that there are these 4 odd maps here that seem boost related may well relate to the fact that there are these 4 odd maps here that seem to be N75 related. So there is something more to this file than meets the eye, obviously. Now I'm just going to press delete a couple of times, try and get rid of all these odd bits and pieces. Let's just go back over to, I swear this thing's getting slower. Let's just go over to the first one then. So let's assume that that is the N75 duty cycle map. Now I'll double click on it and have a look. What have we got here? Well, it looks like we've got engine speed as usual there, doesn't it? So engine speed, revs per minute. I'll just click OK. So I'll assume that one's OK. That looks like it's going to be injected quantity, milligrams per stroke. So it's probably going to be 0.01, and we probably want 1 point after the decimal point. Then we've got this. Now if you've looked at the edc16 N75, you will know that I generally think that these maps run from about 80% to 20%. 80% to 25%, that sort of range. Occasionally you find one that runs from say 95% to 15%, but if you had in mind the figures 80% to 20%, you wouldn't be far off as a usable set of figures. So these outputs I am expecting to be, let's say I'm expecting this to be the N75 duty cycle as the output, so that's what I'm expecting that to be. So it will be a percentage, and so the unit, well, it will simply be a percentage sign really, won't it? And so that will probably be 0.01. That will give us our 80% and our, not 20%, but 29%, 26%. So it's in the right area. I think it might be worth considering. Let's try 1 decimal point. Okay, I don't think we really need to bother with more. We could go for more refinement than that, but I don't think we need it. So there we are. Here we've got almost instantly on start off. So in other words, as soon as the engine is switched on, the vanes are set 80%. So in other words, the turbo is being got ready to supply full boost. So once it's spun up, it will be supplying full boost. So it's got the ability to supply full boost. And as the revs increase, its ability to supply boost will slowly diminish. Often confuses people, but that's the way it works. We are getting more boost, but less ability to produce boost, because if we didn't do that, we would simply overboost and overboost and overboost, and something would break. So that's why these figures are going down rather than going up. So boost might be increasing, but this duty cycle output is decreasing. You can think of that decrease as the wastegate opening, if you like. That's the way many people look at it. Okay, right, so let's just cancel that one and have a look at this one. looks like the same thing, doesn't it? So that would be engine speed, revs per minute. We've already said that that's likely to be injection quantity, milligrams per stroke. We know that that is usually 0.01, and we'll have 1 decimal point. You can see how quick you can do these once you get your eye in. So we're expecting this to be N75 duty cycle, so we're expecting that bit to be percentage, and we're expecting that bit to be a percentage sign, and we're assuming that this is going to be 0.01, and we'll go for 1 decimal point. Okay, well, look at that. See, it shows how quick it is. I'm not a fast typist, I'm not fast at this by any means. But so there we go, we've got a second N75 map. So it looks like we've got a map there for boost, a map there for boost, and to allow for that we've got a boost control map there, N75, boost control map there for N75. So we've got 2 different boost maps, 2 different controllers. So the only thing to consider is which one is being used, or if they're both being used, when are they being used? But we are left with this puzzle. Why do we have 1, 2, 3, 4 other N75 duty cycle looking maps? So that's quite interesting, but I will save that for another day. So I'm going to stop at that point.